Good day, class. In this video, I'm going to show you the solution to your quiz number 1 for the subject ESI 1110 entitled Pre-Calculus for Engineers. So let's start with problem number 1. In this problem, you're going to simplify the expression below, in which we have several expressions inside this parenthesis, and then another expression inside this brace, then raised to a certain exponent 1/2, and this expression inside this curly bracket and raised to another exponent 6. So the principle in simplifying this expression is the law of exponent. So we're going to use this tool in algebra to simplify this one. Now, there are several methods in simplifying this expression. So you can start at the innermost group, which is this expression enclosed by this parenthesis, and then you're going to simplify from the innermost to the outermost, or you can also start at the outermost exponent, which is this number 6, and then you're going to distribute this one to the exponent for the brace, which is 1/2, and to the exponent for x right here, that is equal to 2/3. Okay, but for this video, I will going to start my solution at the innermost expression that is inside this parenthesis. Okay, so in simplifying the expression inside this parenthesis, we're going to apply one of the laws of exponent, in which if we have an expression a raised to a certain number n, and then raised again by another exponent m, so to simplify this one, just multiply the exponents n times m. So that is equal to a raised to n times n. So we're going to use this law in simplifying the innermost expression that is inside this parenthesis. So we have negative 2/3 multiplied by 2. So we now have this one, the second line of our solution. So we have x raised to the power of 2 times negative 2/3, and we have y raised to negative 2 times negative 2/3. So after distributing the exponent negative 2/3 to the exponents of the variables x and y, the parenthesis is now removed. Next is we're going to simplify this one. Okay, so we have 2 times negative 2/3, the result is negative 4/3, and we have negative 2 times negative 2/3, the result is positive 4/3. So the next is we're going to simplify the expression inside this brace. We all know that we have um, same variables inside this one. So we have the x raised to negative 1/3, and we have x raised to negative 4/3, and we also have y raised to negative 1/2 and y raised to negative 4/3. So to simplify this one, we're going to use the second law of exponent right here. Now, if you have a raised to n multiplied by a raised to m, so in this case, we have the same base a and raised to a different exponent. So to simplify this one, simply copy the base and then add their exponents. So you now have a raised to n plus m. So we're going to use this law to simplify the expression inside this brace. Okay, so we have x raised to negative 1/3, then plus negative 4/3. So you have negative 1/3 minus 4/3, and the same also with the variable y. So we're going to combine negative 1/2 and 4/3. So you have negative 1/2 plus 4/3. Next is we're going to simplify their exponents. So you have negative 1/3 minus 4/3, that's negative 5/3. And then negative 1/2 plus 4/3, that is 5/6. Next is we're going to apply this one in order to remove this brace. So we're going to distribute the exponent 1/2 to each of the exponents of the variables x and y inside this brace. Okay, so we have negative 5/3 times 1/2, and then we have 5/6 times 1/2. So the result is negative 5/6 for x, and you have 5/12 for the variable y. The next step is to simplify the expression inside these curly brackets, because we all know that we have the same variables. We have for x raised to 2/3 and x raised to negative 5 6. So we're going to apply this law of exponent right here. So simply combine the exponent. So you have x raised to 2/3 minus 5 over 6. So the result is x raised to negative 1 6. Okay, and then y raised to 5 over 12. To eliminate or to remove the curly bracket, simply use this law of exponent. You have a raised to n and raised to m is equals to a times n, a raised to n times m. So we're going to multiply 6 to each of the exponents of the variables x and y inside this curly bracket. So you have x raised to negative 1 6 times 6, y raised to 5 over 12 times 6. So the result is x raised to negative 1 and then y raised to 5 halves. Now, we are going to avoid negative exponents for our or to our final answer. So we're going to use another law of exponent here. So if we have an expression a raised to a negative exponent n, to simplify this one or to eliminate the negative exponent, so this one will become 1 over a raised to n. So this expression will be brought to the denominator. So the final answer here is simply y raised to 5 halves, and then this expression x raised to negative 1 will be brought to the denominator. So you have the final answer y raised to 5 halves all over x. Okay, so let's proceed to problem number 2. In this problem, you are going to evaluate the expression below. So in the numerator, we have 4 times the expression 5 raised to 2n plus 1, then minus 10 times the expression 5 raised to 2n minus 1, all over 2 times the expression 5 raised to 2n. So the challenge here is to remove the expression that contains the variable n, because if we can remove this variable, so it is easier to simplify this expression. So how are we going to remove this variable n, especially that it is incorporated in the exponent side? So to solve for this one, we are going to simplify first this expression that contains an exponent, in which in the exponent we have a variable n. Now there are some students that simply they multiply directly 4 times 5. So you cannot multiply this one directly. It's because 5 has an exponent that is greater than 1. So if you're going to apply the rule of PEMDAS, you're going to simplify first the exponent before proceeding to the multiplication. Okay, so to simplify or to evaluate this expression, first is we're going to work out the expression that contains the exponent 2n plus 1 and 2n minus 1. So we're going to apply this law of exponent. If you have a raised to n plus m, to split this one into two factors, so that is equal to a raised to n multiplied by a raised to m. Okay, so we're going to apply this one to our expression right here, and specifically the 5 raised to 2n plus 1 and 5 raised to 2n minus 1. Now let's start first with 5 raised to 2n plus 1. So if you have 5 raised to 2n plus 1, this can be broken down into two factors, and that is 5 raised to 2n multiplied by 5 raised to 1, or simply you can use the parentheses, because the parentheses, no, if you're going to apply this one in our expression, uh, this means multiplication. So you have 5 raised to 2n times 5. Okay, so we're going to substitute this expression to our expression right here, and that is 5 raised to 2n plus 1. Okay, so next line of our solution. So this one becomes 4 times 5 raised to 2n times 5, and then minus 10 times 5 raised to 2n. Take note, we have minus 1 here, so you have 5 raised to negative 1. Next is we have a common factor for the expression in the numerator, because in the first term we have 5 raised to 2n, and on this second term you also have 5 raised to 2n. So we're going to extract this common factor. So you now have 5 raised to 2n, and what's left on the first term is only 4 times 5, and on the second term what's left is negative 10 times 5 raised to negative 1. So here we have a negative exponent, so we already know this one by applying the law of exponent from problem number 1. So you have right here, sorry. So as you can see, before we're going to simplify this negative exponent, let's try to cancel out the common factors in the numerator and in the denominator. So as you can see, the numerator contains 5 raised to 2n, as well as in the denominator we have 5 raised to 2n. So this factor will be cancelled out. What's left is 4 times 5 minus 10 times 5 raised to negative 1 all over 2. Next is we're going to apply this law of exponent because we have a negative exponent here. So again, if you have a raised to negative n, that is simply equal to 1 over a raised to n. Simply transfer this expression to the denominator. So you have 5 times 4 is 20, minus 10 times 5 raised to negative 1 is equal to 1/5 all over 2. So 20, this one is simply equal to negative 2 all over 2, and that's 18 over 2. And the final answer for this problem is equal to 9. Next, let's proceed to problem number 3. So in this problem, you are going to factor the expression below completely. So you have 2x to the fourth plus 8y to the fourth. Now, the first step in factoring is you're going to eliminate the common factors among the terms in the given expression. So we only have two terms here, 2x to the fourth and 8y to the fourth. So for the case of the variables, we don't have a common factor among these two terms. But for the case of the coefficients, we have 2 and 8. There is a common factor that exists between them. So for 2 and 8, the common factor is 2. So we're going to extract that one from the given expression. So you have 2 multiplied by x to the fourth plus what's left on the second term is 4y to the fourth. Now let's focus our solution on the expression inside this parenthesis. That is x to the fourth plus 4y to the fourth. Now this expression is similar to the sum of two squares. We all know that x to the fourth is a perfect square because the square root of this one is simply x squared. And we also know that 4y to the fourth is a perfect square because the square root of this expression is 2y squared. Now, in our discussion on factoring the sum of two squares, in some cases it is not factorable. But there are some cases that we can still modify the sum of two squares and then come up an expression that is factorable. So to do that, we are going to use the concept of the perfect square trinomial, in which you have a binomial a plus b raised to some power 2. So the expanded form for this one is simply for the first term is you need to square the first term of the binomial, and that is a, so you have a square. And then the last term, same with the first term, you also need to square the last term of the given binomial. So that is simply b squared. Again, the resulting expression is a trinomial because it comprises of three terms. Now, to get the middle term, simply multiply the two terms in the given binomial. So you have a times b, and that is ab, and then multiply the product to the exponent 2. That is why you have 2ab. Now, we're going to use this concept to our given expression because we all know that x to the fourth is a perfect square. So maybe we can modify this one into a trinomial. That is the only given in this expression are only the first term and the last term. That is, the middle term is missing. Okay, so if that is the case, then we can let a is equals to x squared, so that the first term will be x to the fourth after simplifying. And also we can let b is equals to 2y squared, so that this one is equal to the last term. So again, we let a equals x squared, and then we let b, that is 2y squared, then raise to the power of 2. So again, if this is a, so to get the first term, again, square this expression. So you have x squared raised to the power of 2, and then plus, multiply these two expressions, and then the product, multiply it to the exponent. So you have 2 times x squared times 2y squared. And then to get the last term, you need to square the last term of the binomial, and that is 2y squared, and then squared. Now, we're going to simplify this one further using the law of exponent. So x squared raised to the power of 2 will now become x to the fourth. And then this one, combine the coefficient. So you have 2 times 2, and that is 4. And then copy the x squared and y squared. And the simplified form of this one, simply distribute the 2 here for 2. So you have 2 squared, and that's 4. And then y squared raised to 2, and that is equal to y to the fourth. Now notice that the first term of this perfect square trinomial is equal to the first term of the given expression. Now the last term of this perfect square trinomial, which is 4y to the fourth, is also the same on the last term of the given expression. So the only missing of this expression is the middle term. So we can put this expression, the middle term, which is equal to 4x squared y squared, to our given expression, so that we can transform this one into a perfect square trinomial. So let's do that on the next slide. Okay, again, we're going to use this concept. So we're going to add the middle term. So you have x to the fourth plus 4x squared y squared plus 4y to the fourth. Notice that um, the new expression is different from our original expression, especially the value, because we add something. So in order to preserve the value of our original expression, so if we add 4x squared y squared, we also subtract 4x squared y squared in order to preserve the expression. So again, we modified the expression, but um, the bottom line here is you also, again, in modifying the expression, you also need to preserve the value of the expression. So again, we're going to subtract 4x squared y squared. So you have 2 times this expression, then minus 4x squared y squared. In this way, we preserve the value of our original expression. Next, the factored form of this expression, since we all know that it is a perfect square trinomial, is equal to this one. So you have x squared plus 2y squared raised to the power of 2. So we're going to substitute this expression to this expression. So you have 2 times x squared plus 2y squared raised to the power of 2 minus, again, this expression right here, the last expression, 4x squared y squared, is a perfect square, because if we take the square root of this one, the result is 2xy, then raised to the power of 2. Now notice, uh, in our discussion on factoring, this expression inside this brace is similar to the difference of two squares. So you have, for the difference of two squares, you have an expression a raised to the power of 2, which is similar to this one, then minus an expression b similar to this one raised to the power of 2. So the factors of the difference of two squares are the sum of the two expressions and the difference of the two expressions. So we're going to let a equal to this expression x squared plus 2y squared, and we let b equal to this expression 2xy. So the complete factors of this expression is simply equal to, again, first is the sum of these two expressions. So you have x squared plus 2y squared again plus this one 2xy. And then the second factor is a minus b, the difference of the two expressions. So you have this one x squared plus 2y squared minus this expression 2xy. Therefore, the factors of our given expression is we have the constant 2, and we have this one x squared plus 2y squared plus 2xy, and we also have the x squared plus 2y squared minus 2xy. So each of the factors here cannot be factored out further because this one is already in its simplest form. And this is our final answer for our problem number 3. Next, let's proceed to problem number 4. In this problem, you're going to simplify the algebraic expression below and find its domain. So first, we're going to simplify this one, and then after that, we're going to follow the next requirement, which is we're going to find its domain. Now, this algebraic expression is a combination of rational expression. So this is rational because we have an expression in the numerator and we also have an expression in the denominator. So this is mostly for rational expression. It involves fractions. Okay. Now we also have a radical expression in the numerator. That is a square root of x minus 1 times x squared plus 6x plus 9. Now, the technique in simplifying rational expression is that you are going to factor out completely the expression in the numerator and in the denominator. And then, if there are some common factors in the numerator and in the denominator, so you're going to eliminate that one or cancel out that one. And what's left is the simplified expression. Okay? So, by looking at the by looking at this expression, so we have three trinomial expressions. And the first one, which is in the numerator, you have 6x squared minus x minus 2. So this one is not a perfect square. So the method in factoring this one completely is by trial and error. And then for our second trinomial expression, which can be found inside the radical symbol, you have x squared plus 6x plus 9. This is a perfect square trinomial because the first term is a perfect square and also the last term. And the last trinomial expression is can be found in the denominator. You have 2x squared plus 7x plus 3. Okay, so again, this one and this one, the method in factoring this one is by trial and error. This one, we can use the perfect square trinomial formula. Now these are the factors. Now let's start with 6x squared minus x minus 2. So the factors are 2x plus 1 and 3x minus 2. You can also check whether your factors are correct by using the FOIL method, no? In which to get the first term, which is equal to 6x squared, simply multiply the first terms of these two factors. So you have 2x times 3x, that's 6x squared. And to get the last term, that is negative 2, simply multiply the last terms of the given factors. So you have 1 times negative 2, that's negative 2. Now to get the middle term, which is negative x, so simply add the product of the inner terms and the outer terms. So the inner terms are 1 and 3x, so the product is 3x. Then the outer terms, the product of the outer terms are 2x times negative 2, that's negative 4x. So combine negative 4x and 3x, the result is negative x. So that is how you're going to check your factors using trial and error method. Now the factors for x squared plus 6x plus 9 is repeated, that is x plus 3, then raised to the power of 2. Then the factors for the given trinomial in the denominator are 2x plus 1 and x plus 3. Next is we are going to simplify the expression inside the radical symbol. We all know that the expression x plus 3 raised to the power of 2 can be extracted from the radical symbol. It's because the exponent is equal to the index. Okay, so the x plus 3 can be extracted. So you have 2x plus 1 times 3x minus 2, then x plus 3 multiplied by the square root of x minus 1 all over this expression. Next, notice that we have two common factors here in the numerator and in the denominator. So let's cancel cancel out the first common factor, that is 2x plus 1. Then next, we also have to cancel out the x plus 3. So what's left is you have 3x minus 2 multiplied by the square root of x minus 1. So this is the simplified form of our given algebraic expression. Next is we're going to find its domain. Now, in finding the domain of the given algebraic expression, especially for rational expression, do not base your solution on the simplified form, which is this one. So base your solution always to the original algebraic expression. So here, the concept of domain is simply finding the values of the unknown variable for our algebraic expression, that is x, that will satisfy this expression, or I mean that will make this expression define. Okay, now we cannot say directly that um, the values of x that will make this expression define are all real numbers. It's because there are some restrictions for this one, especially that this expression is a rational expression and we also have a radical expression in the numerator. Now recall, for rational expression, you have an expression p divided by an expression q. So for rational, the restriction is that the expression in the denominator should not be equal to 0. Okay? That is, we're going to solve for the unknown variable x, the value of the x that will not make the denominator 0. Next restriction is for the radical expression. So this one, especially for even index, so you have n root of q. So for n is even, the expression inside the radical symbol q should be greater than or equal to 0, so that the expression will be defined. Because if we have a negative expression in the inside, it will produce an imaginary expression. Remember that in our discussion, we're only limited to expressions that will produce um, real number values. Okay, so if we have a negative expression inside the radical, so it will make the expression complex or imaginary. Now, given that we have two restrictions, that is for rational and radical, so let's evaluate each of these restrictions. So let's start with the rational expression. Again, the denominator here should not be equal to 0. So you have 2x squared plus 7x plus 3 not equal to 0. So to solve for x, we're going to factor out this quadratic expression. So you have 2x plus 1 and x plus 3. So this is by trial and error method. Next, let's solve for the x to each of the factors. So you have for the first 2x plus 1, again not equal to 0. Then for the second factor, x plus 3 not equal to 0. So for the first factor, x should not be equal to 1 half. So this is our first domain, in which x should be all real numbers except negative 1 half. Then for the second factor, we have x should be all real numbers, not excluding negative 3. because these two numbers, negative 1 half and negative 3, will make our expression undefined. Next is for the radical expression. So again, in the numerator, we have a radical expression, and this expression, and I mean this radical expression contains an even index, that is square root. So n here is 2. Now to get the domain of this one, first is you need to eliminate the factors, no? Or you're going to simplify this one by eliminating the factors that can still be extracted, and that is our x squared plus 6x plus 9. We all know that this is a perfect square. Okay, so this can still be extracted out from the radical expression. So what's left is only square root of x minus 1. So this one is already in its simplest form. The next step is by applying this restriction, in which for radical expression, especially for even indices, so the radicand should be greater than or equal to 0. So we let x minus 1 greater than or equal to 0, solving for x, so that is x is all real numbers greater than or equal to 1. So this will be our third domain. Now we have three domains. So to in order for us to know the domain of this expression, so we're going to take the intersection of these three domains. So again, x not equal to negative 1 half, intersection of x not equal to negative 3, and the intersection of x greater than or equal to 1. So if you're going to uh, plot this one on the real number line, you can observe that the common values of x lies on uh, x greater than or equal to 1. So this will be our final answer for the domain of the given algebraic expression. Now you can also observe this one by plotting the given algebraic expression on the x and y axis. So this is the graph of our algebraic expression. Notice that the x value starts at 1, so that is x greater than or equal to 1, and then it propagates towards the positive infinity. So therefore, the domain is x, all real numbers greater than or equal to 1. Next, let's proceed to the last problem, problem number 5. In this problem, you're going to simplify the complex fraction below. So you have the numerator, square root of x minus 1 over 2 square root of x, all over square root of x. So to solve for this one, we all know that the numerator is more complex compared to the denominator, because in the numerator we have another fraction. So we're going to simplify first the expression in the numerator by using this rule in algebra, in which in adding or subtracting the similar fractions, that is with different denominators, simply multiply the denominator, so you have BD, and then for the numerator, the shortcut is cross multiplication. So to get the first term, you cross multiply A and D, so you have AD. Then for the second term, cross multiply CB, so you have CB. And then follow the operation that is given in the problem. Okay, so let's do this. Again, square root of x can be written as square root of x all over 1, and then minus 1 over 2 square root of x. Again, we have the similar fractions because the first term has a denominator of 1 and the second term has a denominator of 2 square root of x. So we're going to use this one. Simply multiply the denominator, so you have 1 times 2 square root of x, so you have 2 square root of x. And then for the first term of our numerator, the shortcut is cross multiplication, so we cross multiply square root of x and 2 square root of x, so you have 2 square root of x square root of x, and then cross multiply 1 and 1, so you have 1. Then copy the operation that is given in the problem, that's minus, so you have minus, then all over square root of x. The next step is we're going to simplify this one, no? By applying the properties of radicals. If you have square root of a times square root of b, If you have the same index, simply multiply the radicand. So you have square root of a times b. So we're going to apply this rule right here. So you have 2 square root of x squared. Notice that the exponent of x is equal to the index, so we can extract x from this radical expression. So you have 2x minus 1 all over 2 square root of x all over square root of x. So here we have a single fraction in the numerator and an expression in the denominator. So to simplify this one, we're going to follow another rule in algebra, that is the dividing fractions rule. So if you have two fractions, AB divided by, I, I mean, if you have two fractions AB and CD, if the operation is division, so the step is proceed to multiplication, but make sure to take the reciprocal of the denominator. So you have AB times the reciprocal of CD, that is DC, and then proceed to multiplication by simply multiplying the numerator and multiplying the denominator. So we're going to use this rule in our um, given expression. So for the numerator, you have 2x minus 1 all over 2 squared of x. Then proceed to multiplication, but take note, you need to take the reciprocal of the denominator. So the reciprocal of square root of x is simply 1 over square root of x. Then proceed to multiplication. So for the numerator, the product is 2x minus 1. For the denominator, the product is 2 square root of x times square root of x. So this one, since they have the same index, so simply multiply the radicand. So you have 2x minus 1 all over 2 square root of x squared. The exponent here is similar to the index, so x can be extracted out from the radical expression. So the final answer is 2x minus 1 all over 2x. And that's it. Thank you for watching.